So this is our second lecture on the Milky Way galaxy, our home. Last time we started talking about the core of the galaxy, the region of space right near the center of that bulge in the middle of the galaxy. So we're going to differentiate between the bulge in the middle of the galaxy and the core. So our galaxy, kind of a big fat pancake with a bulge in here. That bulge is actually made up of mostly population 2 stars compared to the population 1 stars in the disk of the galaxy. The disk is where most of the stars are being formed. So we can see a little bit about what's going on in the bulge, but we're really interested into the actual center of the bulge. That's the core of the galaxy. And so last time I introduced the idea of the radio signals that are coming from the core of the galaxy. Sagittarius A is this collection of radio sources near the core of the galaxy. It's divided into Sagittarius A East, Sagittarius A West, and part of Sagittarius A West is Sagittarius A star, and then that's really what's marking the center of the galaxy. So if you zoom in the VOA, or VLBA even, to the Sagittarius A star, you find, well, the actual active part of Sagittarius A star is an even smaller thing. Okay, and we have all this dust, and it looks kind of like a spirally sort of pattern around here. And again, that suggests there's gravitational motion, gravitational forces and motion going around the center of the galaxy. Okay. Back up a little bit. So Sagittarius A is really one of a variety of things going on in the middle of the galaxy, in this core. And so in that bulge of the galaxy of Sagittarius A, which is Sagittarius B, we have streamers of dust and gas, we have expanding supernova remnants, we have a variety of things in here that indicate that the middle of the galaxy is a very active place. There's a lot of things going on. There's a lot of stars crammed in here. Some stars are being formed, some stars are dying, lots of stars are dying because it's just so crammed inside there. And so we have a lot of supernova remnant just really close together. Okay. Backing up even more, bigger picture view, we actually realize that there are streamers of gas coming out from the center of the galaxy. So whatever's going on at the center of the galaxy, there's actually streamers of gas that are spewing outwards, not just in radio waves, but in X-rays. So it's very energetic in there. This is very, very hot gas. It's shining in X-rays. That means it's superheated gas. It's very, very energetic, very, very energized. So something's going on at the core of the galaxy that is very, very, very energetic, very, very, very active. And so that turns out to be very suggestive. We have stuff spewing out from both directions of the center of the galaxy. Well, what does that sound like? Well, we've seen spewing things before. We saw spewing things around black holes, around T-Tauri stars, protostars. This sounds like accretion. Something accreting into the center of the galaxy and spewing out. But if it's spewing out this far, because we're not talking just a little bit, we're talking tens of thousands, 100,000 light years spewing outwards, that's a lot of force. That's a lot of gravity involved. So let's zoom back in toward the center of the galaxy. So we zoomed out. Now let's zoom back in. And with infrared telescopes, we can see stars very, very close to the center of the galaxy. In fact, the problem is we see a whole bunch of stars. And a lot of these are red giant stars glowing in the infrared. So these are dying stars. And there are a whole bunch of them, meaning there's a whole bunch of stars in there because the smaller stars are not going to show up quite as well. And they're orbiting around the center of the galaxy. In this picture, it marks where Sagittarius A star is right in the middle. And you notice there's not really anything much there. You would, if everything's going around Sagittarius A star, you would expect Sagittarius A star to be enormous object with a huge amount of gravity, and we don't really see anything. In fact, looking into the center of the galaxy, all we see is mainly stars. And that's actually very important because there can be up to 10 million stars within a parsec of the center of the galaxy. Compare that to where we are where the sun is, the nearest star to the sun is slightly over 1 parsec away. This would say that this is death for any planets there, because that means stars be passing so close to each other that they'll be ripping planets away from one another. There's no chance of life in the middle. Red giants tend to be big and obvious in here. There's a whole bunch of high radiation events. Even if there were a planet that were on a star around here, it bathed in radiation, optical radiation, radio radiation, gamma rays, X-rays, the whole works. Life would not be possible in here. The excess of high mass stars in here indicate that, again, all these stars that are dying at the present indicate that something happened about 1 million years ago, that some active event compressed a bunch of gas and made a whole bunch of stars form all at once. And so now a bunch of them are dying all at once. Near the center of the galaxy, we've discovered that there's kind of a disk of gas going around about 2 parsecs from the center of the galaxy. It's very, very close to the Jeans criterion. And so just a very small disturbance could cause stars to form all around that disk of gas. And that'd be a whole bunch of stars forming all at once. We would call that a starburst event. So that's what happened about 1 million years ago, is a starburst event made a whole bunch of stars forming at once. A whole bunch of stars forming at once means a whole bunch of stars dying at once. And that can be very interesting when that happens. We'll talk more about that later. Magnetically, all this gas going around there creates these massive magnetic fields to the center of the galaxy. Again, a little more detail than we have time for this semester. But all this stuff accreting into the center creates these massive plumes of high energy gas spewing out from the center of the galaxy. Again, we're talking things going out here for hundreds of thousands of light years from the galaxy center. And so again, this argues for a massive accretion event in the center of the galaxy. Well, what's there? Well, we've got good enough images now in infrared that we can plot positions of stars. Now, the interesting thing is that over a decade or so, we've noticed these stars moving. Now stars move. We talked about proper motion, about stellar motion before, but normally stars don't move very fast relative to each other. Here we're actually measuring stars moving enough that we can find their orbital motions, and they're all orbiting around the same gravitational center, and that is something right at Sagittarius A star. And so again, for your book, here's these orbital motions here. Again, this is a huge amount of motion for some of these. Here's a animation of the stars going around that spot near the center of the galaxy, and so that suggests again an enormous amount of gravity. How much gravity? Well, because some of these stars are moving at up to 4% the speed of light, that suggests that there has to be about 4 million solar masses. Well, if it was 4 million stars, we'd see that. We don't see that. Indications are that mass is confined to something less than 45 AUs across. That's smaller than our solar system is across. So that's only a little bit farther than the size of the solar system out to, the size of the solar system out to a little bit beyond the orbit of Uranus from one side to the other. So that's a lot of mass. If you try to cram millions of stars in there, they'd be overlapping each other. So you can't do that. Radio variations suggest that whatever is in there is even smaller. In fact, the VLBA in 2008 was able to see things down to about 0.3 AU. Well, 0.3 AU, that's less than the distance between the sun and Mercury. And you have millions of solar masses in there. That's obvious it can't be a star. Okay. But anything else you can think of with millions of solar masses, gravity would pull itself together. There'd be no way of keeping it bright enough, hot enough to keep gravity from winning. It would all collapse down, and in fact, the only thing that would happen is it would collapse down into a giant black hole of millions of solar masses. Well, this is not just a black hole, this is a supersized black hole. And so the term we use for that is a supermassive black hole. Now, one of the things we notice is other galaxies all seem to have a supermassive, several million solar mass or more object right in the center that we don't see, and that everything's orbiting around. So galaxies tend to have these supermassive black holes right in the middle of them.